So looking back at last lecture, we learned how to deal with functions that are being added or subtracted. So if we want to take the derivative of this function here, we see it's got terms that are being added or subtracted. And so if we want to take the derivative of this, so we apply the derivative operator to both sides. And we learned in the last lecture that the derivative distributes. And that's how we handle addition and subtraction. So our question for today is then, well, if the derivative distributes, and that's how we handle addition and subtraction, then how do we handle multiplication and division? So let's consider this function. There are two functions being multiplied. And so we take the derivative of both sides. The question now is, well, how do we deal with this part where we have multiplication? And the answer is the product rule. So the product rule is something that we can mathematically prove and define and have figured out. And we're just going to now accept this as the answer for dealing with multiplication. And this is something that you're going to want to remember. So this says, if you're taking the derivative of two functions being multiplied, then that answer is the regular function f times the derivative of g plus the derivative of f times the regular function g. So let's check this out. So we use the function here. That's our example. And what we want to do here is we want to look at our functions and identify what we have. So right here is our power function. So we know that has its derivative pattern. And we know here is an exponential function, which we know has a different derivative pattern. And this is how you want to choose when you separate these. When you're choosing what is f and g, you want to look at what are the functions. Now, it doesn't matter if you want to choose f to be e of x and g to be x cubed. That's fine. It doesn't matter. However, it's pretty common for people to choose f to be the first function and g to be the second. And so that's what I'm going to do forward here. So we're going to recognize that f is the power function. And then we're going to recognize that g is the exponential function. And doing this already gives us two pieces, f and g. So f goes here and g goes here. So what's left is we need to figure out these derivatives. And so we'll do that. Now that we have f and g, we'll just take their derivatives. So the derivative of f is 3x squared, and the derivative of e to the x is itself. And now that we have all four of these pieces, we can plug this all in to the product rule. So the first thing we have, regular old f. Well, that's x cubed. Now we write in g prime, the derivative of g. That's e to the x. So we'll write that in next. And then we have our plus f prime. F prime is 3x squared, so we'll write that in. And then that's multiplied by g, which is e to the x. And so here is plugging the information into the product rule. And then, like always with math, you want to simplify this. I like to call that cleaning it up. So cleaning it up means simplifying, gather like terms, factoring out your greatest common factor. So that we'll do is our final part here. You should always do this as your final part for your answers, cleaning it up. And so there's no common factors here. There's no canceling. However, there is a greatest common factor here that we can pull out. And there it is. That's our greatest common factor. This would be most likely considered the best looking answer. Again, how you present your answers is subjective, what you think looks nicer. But it's pretty standard in math to have your answer fully simplified with a greatest common factor. And that's our answer. That is the derivative. So let's check out another one. We have this function here. It's a power function times a log function. Since it's multiplication, means we use the product rule. So we want to identify f as being one of the functions and g as being the other one. Now there's a point I want to make here. Because f is so commonly used, you'll see it a lot. However, all of these f's are not the same. All of these f's are the same, but they're different than this f. And that just comes from, there's only so many letters in the alphabet, so letters get reused, and you have to be careful of the context. So just to be clear, I'm going to change this f to an h. But just remember that just because this is f here, and you'll see this a lot with your My Math Lab problems, they'll use f of x. This f of x, this is the function name, where the f down here refers to a piece. It's a product. So these f's are not the same. They're in a different context. So try to remember that and try not to get confused with all these f's because f is so commonly used. And again, to avoid that confusion, I'm just going to call this h. So we'll identify what we're dealing with here. So we're saying this function h is a product of two functions being multiplied together. And so we'll take f to be the power function and g to be the log function. And again, how you choose f and g is dependent upon the function class. So in other words, we wouldn't choose f to be the 7 here. We choose f and g to be one of our function classes. And the functions we have right now are 4 of them. We have the constant function, the power function, the exponential function, and the logarithm function. So let's choose f to be 5x to the 7th and g to be log x. And I just want to say this one more time. We could choose this to be g and this to be f. It doesn't matter. as long as you're consistent through your homework problem, it's not going to matter. But again, for clarity, I will always choose F to be the first one and G to be the second. Now that we have F and G, we need their derivatives. So the derivative of 5x to the 7th, the 7 drops down. 7 times 5 is 35. Subtract 1 from the exponent, and you get 6. And the derivative of log is 1 over x. Now that we have these pieces, we'll plug them into the product rule. So for f, we have 5x to the 7th. For the derivative of g, we have 1 over x. For the derivative of f, we've got 35x to the 6th. And for g, we have log of x. And there it is. We plugged everything into the product rule. And now we'll try to clean up our answer. So we can do something right here. X to the 7th divided by x will get us x to the 6th. So we can clean that up. And there is a greatest common factor here of 5x to the 6th. And so we'll factor that out to get our final answer. And this is the derivative of h. So what happens then if we have functions being divided? So if you look at this, we now have a power function being divided by a log function. And how we handle division is with the quotient rule. Again, this is something that's been mathematically derived. That's how we get to this answer. The math tells us this. And this is, again, something else you should remember. How do we take the derivative of functions being divided? We use the quotient rule. So let's check it out. So we'll identify f. F is always the entire numerator, and g is always the entire denominator. And so from that, we can define f and g. Now that we have f and g, we will take their derivatives. And now with all 4 of these pieces, we plug it all in to the quotient rule. So here's our quotient rule. And I'm just going to start plugging this stuff in. So we have the derivative of f, which is 35x to the 6th. We have g, which is log x. We have f, which is 5x to the 7th. G prime, the derivative of g, 1 over x. And then finally, g, which is log x. And this all is being squared here. And so here is our answer after plugging everything into the quotient rule. And like always, we'll try to clean this up. So first of all, we have an x to the 7th divided by x, which will give us an x to the 6th. And there is a greatest common factor in the numerator. And so we'll factor that out to get our final answer. That is the derivative of h. Let's check out another one. Now, how do you know what to do here? And again, as things get more complicated, don't lose sight of the simple things. When you see this, you know what to do because you understand what this symbol means. It's the same thing here. How do you know what to do first? You look at what symbol you have. You have a division symbol. And so that we're going to be using then the quotient rule. And for the quotient rule, we define f as being the entire numerator and g being the entire denominator. And once we've made that identification, we will take the derivatives. Now that we have all four pieces, we can plug it into the quotient rule. So here it is, our quotient rule, and I'm just going to start plugging stuff in. So we got the derivative of f. And we see that's natural log 2 times 2 raised to the x. So we'll plug that in. We have g, which is x squared. So we'll plug that in. F, which is 2 raised to the x. And the derivative of g, g prime, 2x. And then finally for g down here, we have x squared. And now that everything is plugged in, we'll do our best to clean this up. So something we can do is x squared raised to the power 2. Remember, an exponent raised to an exponent means you multiply. And so 2 times 2 is 4. And that's all the simplifying that we can do at the moment here. So let's go for a greatest common factor. And the greatest common factor in the numerator is x times 2 raised to the x. And now maybe it's a little bit more obvious that an x will cancel. And so we'll be left with x cubed in the numerator. And that is our derivative of h. All right. Question 1. What is this derivative? So let's check this out. We want to first identify what our operation here is, and it's a multiplication. So that means we're going to be using the product rule, which means we have to identify an f and a g. And so we'll identify f as being e to the x, and g being the log x. Once we make those identifications, we then take their derivatives. And now that we have all four pieces, we can plug them into the product rule. So f is e to the x. G prime is 1 over x. F prime is e to the x. And g is log x. There's our answer after plugging everything into the product rule. We'll now do our best to clean it up. There is actually no cancellations that happen here. So all that's left to do is get a greatest common factor. And that is our derivative of h. Question 2. What is this derivative? So we want to recognize there's division here, which means we're going to be using the quotient rule. And with the quotient rule, we identify the entire numerator as f, the entire denominator is g. And once we make those identifications, we take their derivatives. Now that we have all four pieces of that information, we can plug it in to the quotient rule. So f prime is e to the x. G is log x. F is e to the x. And g prime, the derivative of g, is 1 over x. And then finally, g in the denominator here is log x. We'll do our best to clean it up. There's no cancellations here. And all we have left then is a greatest common factor of e to the x. And that is our derivative. So in summary, this is probably our simplest summary yet. Next lecture will actually have the simplest summary of the entire semester. However, don't let the simplification of these summaries fool you. This lecture and the next lecture, while they may have the simplest summaries, are going to lead to the most complex work we've done yet. Our summary for today: product rule, quotient rule. These are both absolutely required that you can do for the rest of the semester. And remember, check out the practice video so you can see more problems and them worked by hand. I'll talk to you in the next lecture video.